Good evening, everyone. Myself, MD Lauddin Ansari, and I welcome all of the students in Gradeup channel for YouTube. So today we are going to solve some problem which has been asked by IIT Bombay previously for the structural engineering. Give me a second. I'll just get to the chat box. So those who are here, those who have joined, please write down in a comment box so that I will come to know you have joined. Then we can start the session. Yes. Good evening, Raghav. Are you able to see the video and listen the audio clearly? Yes. Good evening, Divyansh. Hello, Deepak. Good evening, Julie. I hope you all are attending in app classes also. Hello, good evening, Sunny. So how you all are doing? Is your preparation is going great? Hello, Venkateshan, Vishnu, Siddharth, Jagir, Ranjay, Jitender, Shiva, Deepak. Okay, everything is clear. So as you know, this time, yes, Jagin. Yes, okay. Thank you very much. This time IIT Bombay is going to conduct the examination for GATE, right? So in this series, we will be conducting all the questions related to structural analysis which has been asked by IIT Bombay previously. Hello, Sai. So IIT Bombay, whatever the question they have asked previously in structural analysis, that we will be dealing today at 9:30 p.m. and tomorrow also at 9:30 p.m. So today in part 1 we'll see few questions, and tomorrow also we'll be seeing questions related to that only. So those who have not subscribed, please subscribe the channel and press the icon button for so that you will come to know whatever the notification will be coming. Let us start with the session. As you know, the Gradeup has launched a Gradeup Super, which is a new feature in a Gradeup which will provide you the unlimited access to all live structured courses and the mock test for that particular category. Now, this offer is valid till 31st of August. That is double validity offer. If you'll go for subscription of 12 months, you will be getting offer in that you will be able to get subscription for 24 months. So if you are going to get subscription for 3 months, you will be getting 6 months subscription. That is the offer from the Gradeup. And similar to that, you should remember one thing also, that Gradeup has not diluted its structured planned course. Whoever is going to join, they will be getting the structured planned course till the end of the date. Whatever the course you will be joining, you will be knowing that what are the subjects are going to come, who will be taking that particular subject and at what time. So based on that, you will be able to get into that batch. But similar to that, if you will go for the Gradeup Super, still with the help of parallel to this batch, if you want to go for any of the any of the live classes, you can go and join there. So that is the feature which provided by the Gradeup Super. Okay, let's move to the small introduction. That is 8 years of experience and masters from IIT Bangalore, excise master faculty, and area of expertise, strength of material structures, railway, airport surveying, and soil mechanics. Now, this is the question maybe you have seen asked by IIT Bombay previously, and they have asked in continuation that first they asked that what is the member force, and then they asked that what will be the deformation or deflection at the point C. Now, to solve this question, how you'll approach? Can you just tell me what will be your first approach? What will be your first approach? आकाश एमएसक्यू जो क्रिएट होगा उसके लिए एक सेशन लिया था यूट्यूब में मैंने स्ट्रक्चर का, अगर आप देखेंगे उसमें मैंने स्ट्रक्चर का ही बताया एमएसक्यू कैसे क्रिएट होगा. सो आई हैव मतलब आई थिंक आई हैव गिवन फ्यू few questions, like maybe 5 to 6 questions, which will tell you, okay, Akash, you are absolutely correct. So what should be the first approach? The first approach must be to calculate the zero member force. To calculate the zero member force. Why? Because as you know, okay, zero force. So zero member force by unit method. Okay, Raj is telling by unit load method. No, unit load method you will apply when the deformation is needed. Now to get only the member forces, no need to apply the unit load method. You can apply to get, to get the member forces for the determinate structure of truss, you have two methods which you are utilizing it, that is joint method and a section method, right? So you can apply the joint and section without knowing the zero member force also, no problem at all. But the thing is that if you'll do, you have lot of members involved here. So it's better always, whenever you will get a complicated structure, first identify the zero member force, which will help you to simplify the problem. Did you get that? So first identify the zero member force, which will help you to simplify the problem. So if let's start to find out zero member force. Now what are the few things you need to remember while you are identifying the zero member force? One thing, a single member force cannot exist. If you have a joint at this location, suppose if this member force is there, you can say this must be equal to 0, otherwise it will go somewhere else, isn't it? So single force cannot exist. The second one, you need to remember that if the two member forces or any two forces, whenever I'm talking about the forces, you must always remember that the forces are coming through the member as well as it is coming through your applied load and it is coming through your reaction. So three forces will be at any of the joint: the member force, the load which you have applied, and the reaction. So all I'm considering as singly, I'm saying that it's a force, that's all. Now if the two forces are meeting at a point, this also will not exist. There is only one possibility, that these two must be in a line, and that too they must be in equal magnitude. So if they have equal magnitude and they are in a line in opposite direction, then only they can exist, otherwise no existence of these two forces. And the third one, very important one, while you are going for the zero member force, the third one is that if the three forces are meeting at a point, okay, you take the inclined one, otherwise you will always consider if you have a perpendicular, then only it will be 0. So if you want to get more into that, I have already discussed in Gradeup channel. If you can go download the Gradeup app from the Play Store and you can see all of the videos. You can type there while you're downloading MD space Ansari, and I have taken a lot of classes there. In that you can go for the zero member force and you will be completely knowing how to calculate the zero member force. But here I'm just telling you that at least 3 conditions you must remember. If the 3 forces are meeting at a joint or at a point, if the 3 forces are meeting at a point, what will happen? If two are in a one line, the third must be equal to 0. Okay, so the proof and all other things, you can go to the Gradeup app, download it, go to the MD Ansari, and you will be able to find all the videos which is uploaded there. Now these 3, if we will apply, try to find out in the structure. Let's start identifying the zero member force in this structure. Let us start from the left side. I'm starting to find out the zero member force with the help of only these 3 cases, right? First of all, you will see, I'll just name it. Okay, just wait for 1 second. 1, 2, 3, 4, 5, then 6, so that when I will notice, I will say, you will be able to notice it, which member I'm looking at. Now can you see the D2 member and then 1, 4. So 1, 4 and D2, these two are meeting at a point here. Can you see it? These 3 members are meeting at a point 1. So at a point 1, now 3 forces are meeting. So now if you see the third case, 3 forces are meeting at a point, and if the 2 are in a line, the third must be equal to 0. So which one must be 0? Can you write it down? Zoom. You are not able to see that. Are you getting some trouble there? Okay, let me draw it the half of the portion. Let me draw the half portion only. Let me draw the half portion if you are not able to see that. Only the half portion I am drawing it so that it will be convenient for you to understand. Okay, now you will see here. We will see here. As I told you, just name it some D, then 1, 2, sorry, 2 I have given there here. Okay, just let me name it 1, 2, then 3, then 4, and then 5. Now, can you see this one? Here, please see. Please see. As I told you, can you see this D2 member? D2 member. This D2 member, D1 and 1, 2. D1 and 1, 2 and then 1, 4. These all the three members are meeting at one point. That is at 1. Okay. Just see the point 1, the joint 1. Here at joint 1, three members are meeting at a joint. Now the two are in a line, that is D1 and 1, 2. D1 and 1, 2 are in a line, so third must be a zero member force as per our third case. Did you get that now? So coming to another one, now this is a zero member force. So first one is 1, 4 member, which is zero member force. Now come to the point 4, that is the joint 4. Come to the joint 4 here. How many forces are meeting? Although 1, 2, 3, 4 members are meeting at point 4, 4 members are meeting, but still you can see 1, 4 is already we have given 0. So I can tell you that 1, 2 and 3, these 3 members are meeting at a joint. Now once again the 3 members are 2, 4, 2, 5, sorry 2, 4, 4, 5 and D4. These 3 member forces are meeting at a joint 4. I am ignoring the member 1, 4 because now it is already a zero member force. It will not contribute to any of the forces. Did you get that? Now I can say once again, the 2 are in a line, that member D4 and 4, 5 in a line. So this 2, 4 must be a zero member force. Are you able to see that? Okay. Okay. Thank you, Pritan. Now can you see this one? Here. Come to the top here at joint 3. Come to the top at joint 3. Once again the 3 member forces are meeting at a joint and the 2 are in a line. So 3 and if I will give the name 6 here. So 3, 6 member will be 0. Any problem? 3, 6 member will be 0. Come to the joint 6 itself. Come to the joint 6 itself here. Now here also, as 3, 6 is a zero member force, it will not contribute to any forces. I can say simply that only 3 members are meeting at this point. So if this is C, so C6, 2, 6 and 5, 6. C6, 2, 6 and 5, 6. Only 3 members are meeting at this joint. Now 2 are in a line. This one also will be zero member force. Any doubt? Come to the last one here at joint 2. Come to the last position at joint 2. Now see, all these are zero member force here. This one, these are all 4 member. We have already identified the 4 members are a zero member force. Although at joint, if I'll ask 1, 2, 3, 4, 5, can you see this? At joint 5 members are meeting at joint number 2. At joint number 2, 5 members are meeting at joint number 2. But out of 5, these two are zero member force, which will not contribute to any forces. So now here I can say that only 3 members are meeting at joint 2. Now if only 3 members are meeting at joint 2, 1, 2 and 2, 3 are in a one line. 1, 2 and 2, 3 are in a one line. Can you listen me carefully? So 1, 2 and 2, 3 are in a one line. So the third one which is 2, 5 must be a zero member force. Now I can tell you all these are zero member forces. Now coming to the joint 5 also. Okay, you want to go to the joint D, you can do it. Joint D, how many forces are meeting? Do not consider only 2 forces. Why? Because you have a reaction force also. So at least 3 forces are meeting at a joint, and not any of the 2 forces are in a line. So you cannot say anything about this position. Did you get that? So joint D, you cannot say anything. Now coming to the joint 5. Here how many members are meeting? 1, 2, 3, 4. But this 2, 5 is already a zero member force. I can say simply this is the 3 member forces are meeting, and at 5 this is the 2 member force which are in a line. So this must be also a zero member force. Agree or not? Please write down. Do you agree with it? The member 5, 6 must be also a zero member force. Do you agree or not? Write down in a comment box. So zero member force 5, 6 will be also a zero member force. Okay. I'm just looking to the comment box. Still waiting for your answers. Agree with, till this position? Okay. Okay, Akash. Now, can you see about this point? Okay. Agree. Okay, thank you. Clear. Now, come to this position. Here, if you see the joint 6, see the joint 6. Now, please concentrate on joint 6 here. Please concentrate on joint 6 and you can see one thing. How many members are meeting at joint 6? How many members are meeting at joint 6? Write down. How many members are meeting at joint 6? There is only one member, that is C6. What I told you, if there is only single force, that also cannot exist. So if only C6 member is meeting at this point, because all these are zero, so I can say at this point I have only one member which is still remains, I don't know whether it's a zero or a force which is or a member which has some force, but as I can see there is only one member, so there will be no force in that member. It must be a zero member force. Did you get that? So can you see all the inside members we have seen are zero here. All the inside members are zero here. Now just go to the another part. Now this part, right side is a symmetrical one. Right side is symmetrical to the left one. As you have applied the symmetrical loading, there is no load here. There is no load here. Otherwise it will get changed. Suppose if I'll apply a load at this location. Suppose if I'll apply the load at this location, you should not do what I am doing right now. It is not a symmetrical one. If you are applying the load at this location, you should not do. You should find out. You should find out what are the zero member forces everywhere. Now, but as this is a symmetrical one, what I can say that, yes, total 7 number. Kirtan, you are absolutely correct. Total 7 members, we have found that a zero member force. Now, if you see the right one, this is symmetrical to this one. What you can do, simply you can say the other side also you will get the 7 member which will be a zero member force. Altogether 14 members will be a zero member force. All the 14s will be a zero member force. Now, if all the 14s are zero member force, what will be your new structure? It will look like this. It will look like this, that's all. It will look like this. And a load at the top. Is it okay? Now, this is D, this is B, and this is C. And the length given as a 2L for this and L for height. So if you see the length, you can say directly this will be a 45 degree and this also will be a 45 degree, the angle. And one more thing, they have asked in the question, what will be the member force in AB? Just see left side. I'm using my cursor between AB. So they're asking what will be the member force in AB. Now, can you see this figure? The triangle one, simple triangle. Whether you consider AB or you consider A or in between, whatever the members, all the members will be having the same force. So instead of calculating only for AB, I can simply calculate the member force for the BD whole, and I can say whatever the members they are asking, I can just tell that, okay, this force will be there. Did you get that? Now, to calculate the member force PD, what you will do? First step. Now you came to know till this position. Till this point, it's complete. You are able to get all the zero member forces. Now, what will be your step? How you will calculate the member force? Now, for very simple structure, you can go for joint method. No problem if you want to go for the section method also, but you can go for joint method. Although you are going for either section method or joint method, what will be your first step? You must be crystal clear about that. So your first step must be to calculate the reactions. Your first step must be just calculate the reactions. Now here, as this is symmetry, I can simply say that the reaction at this position will be P by 2 and at this location also will be P by 2. That's all. That's all. So the reactions will be P by 2 and P by 2. Now what you will do after that, apply the joint method. As you have a very simplest form of the structure, you can apply the joint method to calculate the member force. I am considering joint B. I'm going to consider joint B here. Just see. So if you will consider joint B, you have these two members and I will consider all the member are in tension. So now this is our joint B. A reaction is coming, that is a vertical reaction from B, and this is a member force which we will call it as FBD, and this is the member force we can call it as FBC. Did you get that? Now apply the equilibrium equation, that is summation of Fy equal to and summation of Fx equal to 0. So if I am applying summation of Fx equal to 0, you can make a component of the force, that is FBC. You can make a component of the force, that is FBC. So make a component of that and you will be getting two components, which is, now this was 45 degrees, so you will be getting FBC sine 45 degree. I will write down somewhere else, otherwise I will be less with the space. So I will just write down in that equation only, right? So this FBC, this one will be FBC sine 45 and this one will be FBC cos 45. Now I will just eliminate this one. Write down Fy equal to 0, that is FBC sine 45 plus, because both have a same direction, both VB and FBC, what I have considered, the component of the FBC now in a y direction has the same direction. So FBC plus sine 45 plus VB will give you a 0, because we are considering the structure is in static equilibrium. So all the joints must be in static equilibrium only. Now from here, if you will calculate, you will be getting you will be getting FBC equals to sine 45 is 1 by 2 and then it will be 1 by root 2. So it will be 1 by root 2 how much is VB? Okay, VB is P by 2. I'll write down here only, otherwise there will be less space here. So finally, if you'll calculate, this is P by 2 minus, and then 45, it will go there and it will become root 2 upper side, and you can calculate root 2 divided that 2 here, so minus P by root 2. I'm sorry if I'm making very small, I'm writing very small. Okay, so now you will get FBC as a minus sign. What does it mean? It means that it has a compressive. I have considered the tensile stress here in the member BC, but it is showing that it will be in under compression. So simply do not get tensed. This is under compression. So due to that, you are getting your negative sign. Now apply summation of Fx equal to 0 here. Summation of Fx equal to 0. Now if you do that, can you see in this joint, you have FBD and as well as FBC, component of FBC. So write down that will be FBD plus FBC cos 45 must be equal to 0. Now FBC, how much you have? That is minus P by root 2. So FBD, if you will calculate, you will be getting P by 2. Just put that value, cos 45 1 by root 2, and FBC already you have, that is minus P by root 2. You put it there, you will be getting. Now this is showing positive. What does mean? Means whatever we have considered that the member is under tension, it is coming here. So member is under tension. Now you have the member force FBD as well as FBC. Now you can say one more thing here. You do not need to go for other joint. Why you do not need to go for other joints? Because here these are symmetric. here if you see the simplest form which I have made it here, that these two members are symmetric. The whole loading is symmetric. So whatever the force will be coming to member BC will be same as to the member CD. So you can say that member CD forces also will be member CD force also will be same as whatever you got, that is minus of P by root 2. Now you are able to calculate all the forces. So please note it down that FBC is minus P by root 2 and FBD is P by 2. Now what was your question? The AB member force. You can say that AB member force or whatever you are getting for the member BD will be same. So P by 2 will be the answer for this. Now coming to the next question, where he has asked what will be the deflection at point C. Now to calculate deflection you have a different options what you can apply. You can use either Castigliano or unit load, but here I am just using Castigliano. What Castigliano says that you just partially differentiate all the strain energy inside the structure with the load which is acting at the point in the same direction where you need the deflection. So load is acting at point C and he's asking the deflection at point C, so it will be convenient to use the Castigliano. But if you want to use your unit load, you can simply use PKL by A. I will just come to that. But before that, we will just try to calculate the strain energy and we will apply the Castigliano here, right? So first of all, to apply the Castigliano, you need to know what will be the strain energy. So as you know, the strain energy for axial members, the strain energy will be, can you say that? Do you remember that? If you are not able to remember, you can still do that here. This is the strain energy P into delta L, and from here if you put delta L, that P L by AE, you will be getting that half of P square L by AE. I'm just telling those who cannot remember. So now if you sum all the P square L by 2AE for all the members, you will be able to know what is the total strain energy for this structure. Now I'm just telling avoid this one. The inside one already we have made it 0. Inside we do not want to see. Only the outer portion we have 3 members which have a member force. That's all. Now 3 member forces are needed for you to calculate. If you will calculate, can you see that whatever we have calculated there? So member force FCD and member force FBC, where those member forces were, how much the member forces were at that location. Those were minus of P by root 2. In the previous slide, I have just calculated the member force, that is minus of P by root 2. Here, if you see, okay, one more member force, it was FBD. FBD, you can take it, that was P by 2. You will get the total strain energy for the truss. So write it down. Once again, I will be utilizing that symmetry. As you know, FCD and FBC are same. The total strain energy I will write it down for one and I will twice it. Here P I will just write down, that is minus P by root 2 square. Then the length is length of the member. Now what is the length of the member? Here, this length. What is the length here? As you know, this is 2L, this is L. If you'll calculate, now this will be L here, this is also L. If you'll calculate, you will be getting root 2L. So I'll be writing down here that root 2L. So now this is P square L, that's all, divided by 2AE. So 2, then A and E. Now plus summation I'm doing. So 2 members I have considered in a one chance, and second one when I'm writing, I will be writing down for the BD. What will be the strain energy for BD? Once again, I will write down the P square, and what is the P? That is P by 2. So P square L, what is the L? That is 2L by AE. Sorry, 2 is there, 2AE. Now if you add all, how much you will be getting? So if you add all, you will be getting P square L by 4AE, 2 root 2 plus 1. If you add this and take a common of P square by 4AE, you will be getting like this. Any doubt, please let me know. If you have any doubt, please let me know. Now apply the strain energy Castigliano theorem. What he's saying that you just calculate the delta. If you want to calculate at C, you need to partially differentiate the strain energy in the structure with respect to the load which is acting at point C, and you will be getting the deflection directly. So that we will do it here. So partially, if you will differentiate this whole, only P is the variant. So if you differentiate P square, you will be getting 2PL by 4AI, sorry, 4AE, and 2 root 2 plus 1. Now 2, and in denominator you have 4, you will be getting PL by 2AE and 2 root 2 plus 1, that's all. So I hope this was convenient to it was convenient to use Castigliano instead of unit load method here, because if now you are using unit load method, what will happen? You need to calculate for PKL by AE. You know already that PKL by AE summation you need to do to get the deflection at that point. And to apply the unit load, what you need to do, that you need to first calculate the member forces due to the applied load. Okay, that already you have, that is FCD, FBC and FBD, no problem. Then you need to remove all the applied loads and you need to apply the unit load here, because you are searching for the deflection at this location. So you need to apply the unit load in the same direction, unit load. Now you remove that load, apply only unit load, remove all the load, in fact all the load whatever you have. So remove all the load, apply your unit load, then you calculate the member forces, that will be K. So now if you are calculating member force, that will be K of CD, this will be K of BC, then you have a K of BD, then you have already member forces, that is F, you have a member forces due to unit load, that is K. Use that, sum it up, then you will be able to get the deflection. So it's up to you. Now suppose if you are getting some different kind of problem where load is applied some other location and they are asking the deflection at some other location, still you can use Castigliano, but maybe sometimes it is convenient to use unit load. So it's up to you. If you are good in a practice with the unit load, you can go ahead. If you are good in a practice with the Castigliano, you can do it, right? How you will do that in Castigliano? If the load is not applied here, you need to apply a dummy load, that is, you need to apply a load with the intensity 0, with the magnitude 0, then you need to calculate it. So it's better you can go for the unit load also. If the loads are applied and in some other direction, just use the unit load method. So that is how you need to solve this kind of problem if it has been asked. Coming to the another problem here, you have a pin jointed 2D truss loaded with a horizontal force of 15 kilonewton at joint S, and another 15. Any doubt, please let me know in a comment box. Sir, then what will be the deflection at point B using Castigliano? Using Castigliano. See, Castigliano if you want to use, Raga, Castigliano at point B if you want to use, where is the point B? See, here only the deflection will be at this location, Here the deflection will be at this location. So you do not have any load at this location. So you need to apply load. So if you are using that, it's better you go for unit load, no problem. Instead of applying dummy load, you can go for unit load. With the applied load, calculate the member forces, then remove the all applied load, apply the unit load in the direction where you want the deformation or deflection, and then you calculate the member forces, and you can use the PKL by AE to get the deflection. Okay, now coming to this problem, the pin jointed truss. Okay, now this is the truss as it is shown here, and you have a 15 kilonewton here and a 15 kilonewton here, and what he's asking, find the force in member RS. Okay, find the force in member RS. What you will do here, you need to apply some brain. Actually here you have a joint, this is a truss, already it has been told here. So as you know, in a truss the joint doesn't have a bending moment. Now suppose, what is the loading condition here? Here you will be getting two reactions because of this hinge support. Here also you can get the two reactions because of the hinge support. Now this is not the determinate one, this is an indeterminate one. How you will do that? But if you just look clearly or closely, you will be able to understand it, right? How you look closely. You know the concept of the truss, that you will not get any bending moment at the joints, right? So not even any of the single of the truss also has any bending moment. So here if you see the joint V, you can clearly say that, suppose if you have a reaction like this, if you want to see the bending moment, so you can see either of the side. If you see the downside, there is, suppose I have this reaction, the horizontal reaction HW. Now, if you have HW with some magnitude, what will happen? This V at point V, if you want to calculate the bending moment, you will be getting HW into 4. HW into 4. Now, as per the definition of the truss, you should not get any of the bending moment at this location. But still, if you are getting, what does it mean? This HW must be a 0. HW must be a 0 one. So first of all, you have cleared and you have identified that HW will be 0 at this location. What is next? What is next? As I told you, you can identify the zero member forces. You can identify the zero member forces here. So now you can see here, this is a zero member force. As these two are meeting at a joint, they will not exist at all. You cannot do it here because already you do not have two member forces. Here you have 4. Here you have four forces meeting at a joint. But you can apply it at this location, right? Now come to another portion. Come to another portion and try to identify what will happen. Now take a moment. As now this HW has become 0, you can say that you have only VW here and HT and VT at this location. So 3 only reactions you have. So now it is a determinate one. Now this truss is a determinate one, right? Now you can apply your equilibrium equations. So take a moment about moment about T. Now if you take a moment about T, what you can write it down, just see there, VW, that reaction, and the perpendicular distance is this is 4 meter and this was also 4 meter. So and this, so already it has written here, this is 4 meter, so this is 4 and this is also 4. So VW and the perpendicular distance is 8. So VW into 8. Now this VW is rotating about me in a clockwise, so maybe I will take anti-clockwise as negative, which is 15 kilonewton here. The downward side force 15 kilonewton, I will write down negative, so that is 15 into the distance is 4, and here this 15 kilonewton, just you extend the line of action of the force, you will be able to see the perpendicular distance, which is 4 meter. So 15 kilonewton and the perpendicular distance from this point is 4 meter, and that too is rotating clockwise, so I will write down plus. So plus 15 into 4, and you will be equating with the 0. Now this is what I'm doing. Summation of the moment, I'll write down somewhere, summation of the moment about point T equal to this must be equal to 0, because our structure is under static equilibrium. Now from here, if you'll calculate, VW will become 0. What does it mean? VW is 0, isn't it? They are asking member force in RS, but while calculating the zero member forces and the reactions, you are able to see that you are proceeding in some other direction. Although if you see the question in one instance, if you see the question, you will be saying that okay, maybe I have to apply the joint method, maybe I need to apply the section method. But see here, my dear students, no need to apply joint or section method. They have provided the question in that way. Now once again, this VW has become 0. Now VW is also 0. If VW is 0, this is 0, this is 0, this member was 0, now VW is also 0. Now if these two are 0, can you see once again what I told you? The two members are meeting at a joint. Now if these two are 0, these two are meeting at this joint. If these two are 0, only two members are meeting at a joint. These also must be 0. These also must be 0. Did you get that? These also must be 0. From second rule, just you imagine what I told you in a previous slide. This is the second case which I gave you, that if the two member forces are meeting at a joint, they cannot exist. Now here, if come to the joint R, come to the joint R. Now this is a zero member force. This is a zero member force. What will happen to joint R? Two members are meeting, that is RS and RU. If RS and RU are meeting at this joint, what will happen? The two member forces cannot exist. Simply you can say that RS member has a zero member force. So without going to any joint method, section method, you are able to say that, okay, member force in RS is zero. That's all, nothing else. Our problem is solved. Any doubt? Any doubt? Okay, we'll move to another one. We'll move to another one. Here he's asking about degree of freedom of the following frame. Now, what is the degree of freedom? Degree of freedom means if you have already studied. Suppose this is a cantilever beam. What is the maximum deflection here you can get? What is the maximum kind of deflection you can get it here? This point can go like this. This point can go like this. In a 2D, this point has 2 degree of freedom in X and Y. It can move. The movement position of the joint only we need to consider for the degree of freedom. So this point can move in X direction. This point can move in Y direction, and still the point can rotate. The point has some slope at this location. So you can say there are 3 degree of freedom for a single free end. For a single free end, you have 3 degree of freedom. Similar to that, for a rigid joint, you have 3 degree of freedom. How much? How you can say that? See here. As you know, for a rigid joint, if it will get deflected also, after deflection also, after bending on deflection, everything. Can you see here? Is it visible to all of you? Is it visible to all of you? Here, this joint is moving from here to here. So this is a movement in Y direction, whereas this is the movement in X direction. And at the same time, although it is maintaining the 90 degree, because it is a rigid joint, and that is the property of the rigid joint, where it will maintain the same angle. This is the property of the rigid joint, where it will maintain the same angle. You can imagine it has been welded. It has been welded. It has not been pinned. This is not a pinned connection. It has been welded. Now what will happen? As the rigid joint can maintain 90 degree, but it can rotate. So the rotation part is also there. It has been rotated. The whole joint has been rotated like this. So for a rigid joint, you have 3 degree of freedom. Now come to this question. Degree of freedom. Here you have 1 degree of freedom. It can rotate here. Here you at this joint you have 3 degree of freedom. At this joint you have 3 degree of freedom, and at this joint you have 3 degree of freedom. Sorry. At this joint you have, this is a pinned connection 1, and at this joint you have 1 degree of freedom, that is rotation. You will get the slope here. You will get the slope here, right? One doubt you may get in your mind that, sir, while doing for the truss, the rotational part we are not considering. Why? Because that was simple rotation. Here the rotation means it will get bent like this. Can you see this? Please do not get confused with the rotation part of the frame and the truss. In a frame, all the members are connected with the hinge, with a pin connection. So now if you will apply the load, it will simply come like this, the straight member. If you will apply the load here, it will simply come to like this position. So this is not slope. This is a pure rotation. Here now, although I'm using the word rotation here, but you can still imagine how it will get bent due to some load. How it will get bent. So due to this kind of loading, it may get bent like this. Can you see this? So it may get bent like this. So at this location, the slope is still, it is not the pure rotation. You are getting the slope. If you draw the tangent at this point, you are still getting some slope here. That one we are considering, that it has degree of freedom. It has a movement where it can get a slope here. Did you get that? So do not get confused with the truss one and the frame joint, frame hinge location. These two are two different things. And we will see one question I think I have where the internal hinge is present. I will be explaining that too also. So here, what is the total degree of freedom? That is 1 plus 3 plus 3, 8. So total degree of freedom you have 8. And the inextensibility of the structure, if you consider that all the beams and the columns are rigid, then you should subtract 3. If it is inextensible, you are assuming, then you should subtract 3, that you have 3 members here, you will get 5. That is the degree of freedom. That's all. That's all. Coming to the next problem here. This is, I think, IIT Bombay is this type of question. There is no. It's a favorite one. They have asked several times. You'll see how many questions I have related to the same kind of structure. They are just making few changes, and they have asked a lot of times. Now, if you see here, the kinematic indeterminacy of the plane frame, he's asking about the kinematic indeterminacy. That's all. And what he's asking, that disregarding the axial deformation, means what he's telling. He's telling that all the members are inelastic. So all the members are rigid. That's all he's telling about. Now, if you can see, what is the kinematic indeterminacy? That is once again the same. The number of total degree of freedom is nothing but the kinematic indeterminacy of the truss or frame. So please count it, how many of degree of freedom you have here. For this hinge, you have 1 degree of freedom. For this location, you have 1 degree of freedom. For this rigid joint, you have 3 degree of freedom. Now, this is not rigid one. This is hinge one. This is hinge one. Now, you must imagine one thing. As this is hinge, as this is internal hinge, what will happen? So, once again, do not get confused with the truss pin connection. Why? Because if you have an internal, see, these two are the truss members. Suppose these two are the truss member. If this will go like this, still the member will rotate like this. The member will simply rotate. It will not get bent. There will be no slope. There will be no slope like this. But in a frame, if you have an internal hinge, suppose like this. I'll draw for your understanding. I'll draw it for your understanding, so that later on also you will be able to understand and get a feel of that. Get a feel of that, because you should not consider this is the only problem they can ask. They can ask different kind of problems. Now here, this can independently make a slope with bending. You know, if it will get bent, the elastic curve of the beam can make independent slope. Now suppose if I am applying the load like this, you just consider I am applying the load like this in this structure, and due to this load, this member, the beam has been bent like this. This is the elastic curve. Now what will happen to this location? Can you see this? Due to this, maybe this will get bent like this. So these two are independent to make the slope at this location, at this joint. These two, column and the beam, are independent to make the slope. The slope of the beam is no more dependent on the slope of the column, whatever he is making. So the two different degree of freedom will be there for two different slope. Whereas the joint itself can move in x and y direction. So the joints can still can move in x and y direction, and the two different slope also you will get. So total movement which it can do is 4. So for any internal hinge in a frame, you have 4 degree of freedom. Always remember, that will be very much helpful while you are solving if you have an internal hinge inside the frame. Now at this location you will be having, okay, at this location you will be having 4 degree of freedom. So count it, 3 plus 1 4 plus 4 8 plus 1 9. So total is 9. Total degree of freedom is 9. Now as he has already mentioned that disregarding the axial deformation, I can simply say that 3 members, subtract it, you will getting 6. I hope all of you are correct. Yes, I can see. All of you have given the correct answers. All of you have given the correct answers. Did you get that? Okay. Coming to the next problem. Once again, see, that's why I was telling that this kind of truss is very much favorite for the IIT Bombay. So the plane figure shows below is stable, or first of all you need to understand that whether it's stable or unstable, because you have two options here. Statical determinacy, we will get it later on, but stability and instability you must understand first whether it's stable or not. Externally, you know already, externally to get a stable structure you need at least 3 reactions, which is already with you. So you can say that okay, it's externally stable. Now internally, internally there is one chance only that if you have an internal hinge in these locations, at this location it will just rotate and the structure will collapse. So you can say that internally also it is stable, as you do not have any kind of mechanism there. As you know, in any of the truss frame, if you have three hinges, there is a problem. It will get, you know, internal problem, internal stability problem. So externally it's a stable. Now coming to the determinacy part, how to calculate the static determinacy of the frame. Now to calculate the static determinacy of the frame, as I have already taken a class in that, if you'll go to the Gradeup app, to calculate the static determinacy, you can do the 3 times of number of cut minus force needed. Now please remember few things here. You need to cut the frame such that you will be getting stable cantilever, then stable cantilever open. That's all. So stable cantilever open structure, you need to cut the frame in such a way that you will get the stable cantilever open structure. Now cantilever means what? What kind of structure you are calling as a cantilever? They have only one support, they are not with the other support. So here if you will cut it, obviously I can cut the member like this, but still I can say, if I will draw the diagram, this is not okay. Now this is open. Open means what? If you have a loop, that also must be cut. So I do not have a loop here, so I will just ignore this part, and I can say that okay, with one cut only I can make this as a cantilever. But is it a stable one? No, because you have a hinge at this location. If you apply the load, it will simply collapse. Either side, any of the side. Now what you need to do, there is only movement, isn't it? It cannot translate, the joint cannot translate in x and y direction, but it can rotate. So the rotation, to stop the rotation, you need to apply the moment. So that is the one force needed to make it a stable cantilever structure. So if you are making it a stable cantilever structure, you need one force here. That's all. Now what about the other part? If you draw it here like this, if you draw, now although it's a cantilever, but it is not stable. Why? Because it can simply translate in the horizontal direction, as well as it can rotate about this hinge. So there is a rotation and there is a translation, the two movement you have. So you need to stop these two to make it stable cantilever structure. Now if you will apply a horizontal reaction, it will be stable. So one force, then one moment you need to apply to stop the rotation. So two forces you need here to make it a cantilever open structure which is stable. So now this is two forces needed at this location and one forces are needed at this location. So total needed force to make it stable cantilever are 3. So 3, and number of cut, how many made? Only one cut I applied. So 3 into 1 minus 3, you will be getting 0. What does it mean? There is no indeterminacy in this frame, and this is statically determinate truss. So our option must be A, which is stable and statically determinate truss. Did you get that? Coming to the another problem. Now once again it's the same kind of problem. See how many problems they have asked. This IIT Bombay. How many problems they have asked? Consider beam as axially rigid. See, this first statement itself is, you know, very informative. Consider the beam as an axially rigid one. See, the first statement is really very informative, because he is asking about the degree of freedom. As I told you, the degree of freedom here, one translation is allowed, okay, one rotation is allowed, okay, 2, so 2 is here, okay, 1 here, 3 degree of freedom at a rigid joint, 3 here. For the rigid joint you have 3 here. For the hinge you have 1. So all together if you will add, you will get total degree of freedom as 9. Now as you have already solved, if you will subtract the total number of member, your answer will be wrong. Your answer will be wrong. Why? Because they have already highlighted this portion that beam as axially rigid. They are not telling that the whole all the members are rigid. They are just telling beam is rigid. What does it mean? This means that this beam is only rigid. Then what you need to do, if the only beam is rigid, you need to subtract only 1. That's all. So those are rigid, you need to subtract, that's all. If you'll subtract this, you will be getting 8, which is the degree of freedom here. So answer will be 8, the degree of freedom, answer will be B. Did you get that? So answer will be B, because already they have written here the beam is axially rigid. Axially rigid, only beam. They are not talking about all the members of the frame. They are not talking about all the members of the frame. Okay, I hope all of you have enjoyed, and tomorrow at 9:30 also I will be coming with the rest of the questions which has been asked in structure from IIT Bombay. And you go and subscribe, press the icon button, and if you like this session, please do like. And that's all. You can see there is a rank up gate civil engineering course going on. So it's a fast track revision course where I will be teaching along with the other very experienced faculties, and you can join me. You can join this course, rank up gate civil engineering, in Gradeup app, where we'll be covering more than 350 plus hours of live classes, and the practice questions more than 3200, and study notes, full length mock test, and daily subject test. And for any other query, you can go to this number, you can dial this number, whatever the query you have. So this rank up course is a fast track revision course which will be needed for some of the students who need to do the fast revision for their gate 2021. And as I told you, there is a double validity going on a Gradeup Super. This is a super feature launched by Gradeup where you'll get the unlimited access to all the structured live courses and mock tests. So avail this facility, which is very much beneficial for all of the students who are aspiring. And as for the double validity, if you'll go for the subscription of 12 months, you will be getting for 24 months. So that's all for today. Subscribe it, and whatever the PDF will be there, you can go to the description box. There you'll be getting the link for the Gradeup channel, and in Gradeup channel I will be uploading whatever I taught it. So all the documents will be there, PDF documents. You can go and download it. And tomorrow at 9:30 I will be taking class in YouTube only for the rest of the structures. So that's all for today. I hope all of you have enjoyed. Thank you very much. Good night.